Another draft physics video presentation. This one a response video to Sabine Hossenfelder. Another one. And this is an older video from like 4 years ago. Completely changed her production values. Is kind of funny. But anyway, still trying. You know, it's good to polish your presentation, I suppose. To some extent, that's good. To some extent, it's a little bit dishonest and bullshitty, but whatever. So he's still trying to, jazz it up a little bit.
Did you know that Einstein didn't win the Nobel Prize for special relativity and not for general relativity?
Yes, and he shouldn't have, right, because those theories are kind of wacky and silly, and, Nobel Prize people are afraid to say that was a right answer. So, yes, he got it for the paper, demonstrating a logical argument about how photons are more than you think.
Either? No, he won it for demonstrating that light is not a wave. So then is it a particle?
So is there no point, right? He obviously didn't demonstrate it to convince any of you, so what's the point? He didn't demonstrate anything. He just correlated something. He made a point that the elements of what we call a photon are quanta of energy is in them. That these photons are made of something that comes in clumps. And you won't even accept that, frankly. So, yeah, they shouldn't have bothered giving him the Nobel Prize for it because you people are completely unconvinced.
Particle. No, it's not a particle either. Asking whether light is a wave or a particle is like asking whether YouTube is social media or television.
Yes, well, the simple answer is an answer we all can know is the really simple thing to say is that particles, can be sent. Soldiers can look like waves of soldiers. Bullets can look like waves of bullets. But it's really hard to think of a soldier, an individual soldier, being a wave. Waving a jellyfish. I'm a jellyfish soldier. That doesn't, or a bullet being a jellyfish bullet. That doesn't really work. So you can clearly see, now her most recent video is on the subject of emerging properties. You can clearly see that waves can emerge out of particle behavior when they're in a group, right? The big G. When they're in a group, they can do something they can't do as individuals. But they're still individuals in the photon example. There's no reason to believe there's any connection between this element and this element, or this element and this element, besides just the circumstance of hitting something at a time. And that's what we'll call a photon. It's when something hits at the right timing sequence, photon. But the photon can be made out of this one, and this one, and this one. They can be the photon. Or these three can be the photon. Or any arrangement you choose can be the photon. That's the simple answer. The little stuff creates an environment that can look wave-like, but the wave is a contained thing. We know this thing has polarization. We know this is a contained size. All right? So we know it's not spreading through the whole universe or doing any of that mush. So if you just put the facts of what a photon is in a list, like it has ray length, so photon has a length. There's an amount of that it keeps going over time. So this is a time-dependent feature. Its length, how much of it there is. And then we know it has a frequency inside of that length. And the frequency is the same as what we call a wavelength. The two are proportional. And what we're really saying is that each little bit of the wave is always the same. It's always the same intensity. You don't have like a giant piece of photon, and a little piece of photon, and a giant piece of photon. And no, it doesn't do that. And it has this consistent speed. All these little bits move exactly the same speed. That's all. Those are the facts. And they put them together in some way that says this is not some kind of solid thing, and none of these things are in any positions, and all of this woo, and there's just no need for it.
It's both. It's neither. And it's the same with light. Light is neither wave nor particle. But what does that mean?
It means you're kind of almost certifiably insane. It's a horse and an elephant. It's grass and it's a tree. It's the sky and the ground. Yeah, if you walk around doing that all day, you're supposed to be put somewhere. You know, little jackets they have, and, you know, they inject you with shit just so you go, you know, so you stop talking crap. You know, frankly, it's just crap. I mean, it's overtly a crappy answer to say it's both on and off. It's a stupid answer. It's never the right answer. Ever. It's up and down. No, it isn't.
It's a particle. Einstein won the Nobel Prize for explaining the photoelectric effect, which works as follows.
He didn't really explain it, so let's not go that far. He pointed out a limiting factor, okay, a factor that kind of indicates this can't be this amorphous thing you've made it into, because it's doing this very discrete binary thing. So he's just kind of demonstrating this is a digital function, not an analog function. This is this has something to do with the character of the bits. You know, not, some sort of how tall the gremlin is.
Take two metal plates, one uncharged, one negatively charged. Shine light on the first plate and then measure whether the charge on the second plate changes. The light knocks electrons off atoms. These electrons are...
Right. Now, we don't even, they don't even really theoretically understand exactly how electrons are motivated, what their nature of their momentum is. I would argue that the nature of their momentum is that they really do need to be pushed by a ray. And as soon as you stop pushing them with a ray, that is, as soon as there stops being energy, photons pushing them, that they lose their motivation to continue moving, okay? They simply run out of the gas that runs them. So part of what you're really arguing is how much energy, how much ray did you push the electron with will decide how far it goes. So if I push with gamma rays, I'll get a lot further than I'll get with like ultraviolet or infrared, because I can't make a continuous infrared ray as easily as I can make continuous, as funny as that sounds, other kinds of forms, because those forms will be caused by a certain kind of source of energy. Like if I keep pushing electricity in, I keep pushing photons out. Well, what am I really pushing out? I'm pushing out energy, and the energy can push an electron, and continue to push it, and continue to push it, and continue to push it. So, even that part isn't fully understood. But clearly the experiment is just indicating that the electrons should have a resistance to going to the plate. So you create a resistance, a force that opposes them, and if they're shot off at a certain speed, then they'll overcome that resistance. So that's really what they're measuring. That only with certain kind of light do you hit the electrons, do you move the electrons, do you jiggle them, do you push them with sufficient energy to get them to cross the barrier, is the real point. So this is good because it illustrates red light. Okay, so it's red and the wavelength is higher, the polarization. So that's a key thing here, right? That no one really pays any attention to, but it's a fundamental fact that there's this huge proportional relationship between the frequency and the height of the wave. So the longer the frequency, the higher the polarization. So this would be a description of polarization. So the tighter the frequency, the higher the frequency, the smaller the surface the wave hits. So this is like a critical thing to understand, is that the difference between red and blue light is essentially a 50% difference. The red light falls on a much larger surface. The blue light falls on a much smaller surface. So you could argue that there would be a simple correlation between what's the likelihood of me hitting an element that was, say, this size. You're right. Now, I have the bigger the polarization, the more likely it is I'm not going to be able to hit it twice or 3 times. But the smaller the polarization, the more likely it is that I will hit it many times with the same beam of light and therefore have a reaction. That's based on the fact that multiple bullets hit the same thing. So if I'm spreading the bullets, even though I'm firing fewer of them too, which is the downside, so the red light is spreading the bullets over a larger area and it's firing them less frequently. The blue light is firing them much more rapidly, plus confining them to a much smaller part of the target. So these are key facts, okay, just real facts of what light is that they never talk about. It's like this subject doesn't exist. Okay. So just pointing out that the red has got big polarization. Less likelihood that the same pieces of that ray will hit one single electron. Say if that ray wasn't a wave and you understood it as being nodes, little bullets fired in a row, and that they're a little bit out of alignment, you'd understand that the narrower I can make that alignment, the more likely it is I'm going to hit the same electron with 2 pieces of that ray.
Held by the second plate and can only reach it if they have high enough kinetic energy. The expectation that physicists had in the 20th century was that increasing the intensity of the light would give more energy to the electrons.
Right, so what they were thinking is that, this is kind of a bogus theory to have from the beginning, but anyway, that, okay, these are the rays. So if I make more rays, but each one of these rays has the same unlikelihood of hitting an electron twice. So what we're really saying is that you could think of the electron as a pendulum. And what you really need to do is, when you hit it once, it swings to this position, but then it goes right back again. And the key to getting this extra energy, to fly faster across the barrier, is you have to get the pendulum up to here so it can swing all the way over here, that kind of thing. So it can break out of its gravity, break the string. You could almost argue that so you want to break the string that's holding the electron, and so then it'll swing all the way over or whatever. So it's just about a momentum. You want to add enough momentum to the electron to create this could be a rebound, or this is like a trampoline. The deeper you go into the trampoline, the more energy you're going to go back up with. So you're basically saying how deep into the trampoline did I go? That'll give me more force coming out. And so the argument is if you hit this without it being at perfect frequency, that is this thing is still moving up when you hit it again. So the key would be is if it starts to move back down and then you hit it again, you won't get up here. The only way you can get up here is you have to hit it again before it swings down, and not too soon, because it can't go any faster than the swing rate. So the idea is whatever frequency matches that, or is less than that, like I said, you can hit it a little earlier, that will get you up here. So if you can hit one electron twice with energy at the right frequency before this swings back down again, you'll have your high enough energy that when it swings back down, it'll be released at the proper speed. And what light will do that? Well, this red light has low chance because there's low chance that you're going to be able to hit 2 electrons. Now, you do it now and then, so it does happen. Once in a while, the red light will produce a winner, but it's very rare. And the more I narrow the polarization of the light, the tighter the light is, the more likely it is to hit the electron, and the higher the frequency, the more little bits there are, the more bullets are being fired, the higher the likelihood I'm going to hit the target. I'm going to hit an electron twice with the same ray, so it'll have the right timing, I hit it before it went back down. That explanation does work. Now, it's not perfect. You could find flaws. You could say, but I'm just saying the very idea that the electron is in tension, and the key to the whole thing is knocking it out of its tension with enough momentum. You have to give it enough energy to be released from its gravity, and that there's rules about how you acquire that energy. You can't acquire it in slow pokes. You can only You can only add energy to the system if you are constructively adding the energy. You have to hit it at its resonance frequency or above for you to add energy.
And allow them to reach the other plate. But that wasn't so. Instead, it was increasing the frequency of the light that gave more energy to the electron.
There, so the green light is much smaller, so that's a good example. See, it's showing you the polarization is smaller. The light is hitting a smaller amount of surface. You have much more intensity just by the fact that the polarization is more narrow. The narrower polarization is a kind of intensity enhancer. So the intensity of the gamma ray is not so much just because of the tightness of the fact that the bullets aren't very far from each other. It's also the fact that the bullets are being fired in a much straighter line. They're all hitting a much smaller surface. That's I'm just saying, it's the rational way to look at the facts.
And allowed them to reach the other plate. Einstein explained these observations by postulating that light is made out of small packs of energy.
Right, now this was the tricky part, right? Because this is sort of like the difference between field lines and lines of force. Not getting the emergent thing versus the elemental thing. The field lines are the emergent thing. The lines of force are the elemental thing. And with photons, again, we call it a photon. And what we're missing from that word is something really quite fundamental, is that we know it has to have a certain ray length. There has to be a certain depth in time. The photon has to have a certain depth in time, or we don't see it. Like a frog will see this as a photon, just 3 of these things. It doesn't need this one. We, on the other hand, need this one, and maybe even this one. So if we don't get the ray in this form, we don't see it. It's still a photon, obviously, because a frog will see it and say, photon, I saw that. So I'm just saying, this is how weak our language is. We're calling this emergent thing, okay, this thing that's made out of more than one element, we're calling that a photon, when it's not one particle. It's made up of, even if you think it's a wave, you'll know it's made of nodes. It's made of pieces where it's on and it's not on, and it's on and it's not on. And that's the signal it's sending, is on and not on. And I could explain even any kind of system where you're going to, say if I had a bunch of stuff that was just flying at me at all kinds of different rates, all kinds of different positions, a bunch of bullets, and I could take a target and I could move it towards and I could move it in, and I moved it at the same speed that the force was traveling at. So the little electron, I could jiggle it at a very high rate. I could make it go very fast. Well, the fact is that if I force this surface to go this way, what am I doing? I'm moving it away from this force. I'm going to change where it's all going to reflect, because it's all going to have to wait till it gets here to reflect. So the period between here and here, there won't be any reflections. Nothing can reflect when I'm moving this away as fast as that stuff's coming towards it, right? So somewhere in the reflective signal, there's going to be a 0. Nothing. Because I'm moving the surface away. So if I move the surface away from the basketball at the same speed the basketball is traveling, the basketball can't hit the surface. But when I'm doing the opposite, when I'm moving it that way, okay, now I'm more likely to hit a whole bunch of basketballs, because the ones here, here, and here are all going to get hit when I move the board out. And so now I'm going to have a bunch of stuff. And then I move it back the other way, I'll have 0 again. And then I'll have a bunch of stuff. That's frequency. That's how photons are made. Electrons move on surfaces. You hit them here, move them. The movement is translated through the material at some maybe 40% of the original speed, because it takes time to translate the signal. And then the other surface just does the same thing. It just says out, out, in. It creates a surface parallel to the surface that went in, and that surface creates a reflection, okay, that will carry the same on, off, on, off, on, on, off. Simple explanation there. Mechanical, simple, complete enough, answers the questions. We don't need this wavy woo. They've never proven their wavy woo. They just say, we have decided. We have wave-particle duality. We're pretending there's no such thing as particles. That's what they've definitely concluded. They don't believe in any duality. They are clearly wavicists. They draw it as waves. They call it a wave. Why are they pretending they're giving any concession to particle theory at all? Because they're not. Clearly.
Photons, whose energy is proportional to the frequency of the light.
So again, this is sort of a mistake. It's also proportional, right? I could say exactly something else that's exactly just as accurate. I could say it's also proportional. The energy of a photon is also proportional to its polarization. I could say the same. I could say that statement and be absolutely correct because you're confining the space the energy hits. Clearly.
It's a wave. This is a compacted.
The more I spread a bullet out over the surface, the vastly different the effect it's going to be on the material, right? So if the bullet breaks into a bunch of little dust, and I hit you with a pile of dust, you'll go like, whoa, a little bit of dust hit me. No holes, no damage, no organs torn to pieces. But the more I confine that bullet, the more damage I can do. And the same is true for atoms. Atoms feel the same way. Hit them discreetly with a lot of energy, and you can break them. Hit them with a lot of energy over a lot of surface, and you're not going to do anything to them.
When I was your age, we stored music on them. Now the neighbors hang them in the trees to scare off the birds, but I know something better to do with them.
Sit and spin? You could tell us what you could do. Oh, I guess she's going to show us this is better. Okay.
This is a laser pointer, which I got at the University of Bern for a seminar that I gave. Great city, you should visit.
Whatever. Sorry, I mean, 4 years ago, laser pointers still weren't miraculous, even 4 years ago. I mean, 20 years ago, okay.
Here's what happens if you shine with the laser pointer on the disc.
Right, so this is just duplicating the diffraction gradient. That means a lot of little one-slit experiments over and over and over, piled into the same area. So you're breaking the light into with tiny, tiny little slits and diffracting the light a lot. The light diffracts more, the narrower the gap. So a bunch of tiny little gaps that all spread light a whole lot, and you remake the photons in certain discrete positions, and the positions are very far apart from each other. So instead of the traditional, it's nothing like the traditional pattern. I mean, nothing like it. I mean, it's completely different on scale. I mean, the dimensions are so dramatically different. So if I do a traditional two-slit experiment, at this distance, say it's 1 meter, 2 meters, it doesn't matter. This will be how big the pattern is, right? The pattern will cover this much ground. And you'll have your on, off, on, off, on, off pattern. Okay, we'll call these the offs. All right. But what you do when you have these little tiny, when you have a whole bunch of these little slits, what you end up doing, isn't spreading the light by the same dimensions at all. This pattern is absolutely huge. It's just gigantic. And all you have is on here, and then you have an on here, and you have an on way over here, and you have an on way over here. So just multiply this times 10, or 20, or even 30 in terms of size. I mean, these distance, at 1 meter, you'll have 1 meter between this on and this and the next on. It'll be 1 meter of distance between them. They're so spread out now. Very different results. Now, and the key thing is, if I put round light in, I'll get little round balls. If I put a star in, or a square, I could draw a star, right? Can't be that complicated, right? Yeah, a little star this way, and yeah, that's a star. 8-sided star. Well, anyway, I put a star in, then I'll get stars here. And I got a star here. And I got a star here. I'll get the images will be sent to these locations. completely blowing up any idea of randomness or wave functions. A wave function can't do that. Randomizing, saying that it doesn't matter where it goes through the light, doesn't matter how close it is to the slit, right? I mean, we're going through a slit, doesn't matter whether it's right near the edge or right through the middle. All of that stuff where you negate all of that and just say, no, it's just some probability curve thingy. No. That won't get you an image at all these locations. So they already know there's a huge flaw in this theory, and you'll pay no attention. No attention whatsoever. They just couldn't care less that what they're saying doesn't make any sense and is not consistent with the actual facts.
Instead of seeing 1 point, you see 3, 4, or if you look closely, 5. What is that?
So understand, because she's hitting the surface of that, the CD is cut in arcs, so you're getting the arc of the CD, but it's almost the same as just having vertical lines. So that's like the two-slit experiment, right? You can go in, you can go up and down anywhere you want, but you can't go side to side, right? So it's this, but it's Newton's rings. So if you did it with mixed, you take all these things and mix them, then you'll get this pattern all over the space. Okay, it'll go, the pattern won't be just this way, it'll be this way, it'll be this way, it'll be this way. It'll go all through that whole 360 degrees. So if I make it a random pattern, then I will put this pattern everywhere. And there'll be a geometry to it, but I just mean the pattern goes up, and goes out, and it twists this way and this way. I mean, it goes the whole clock face. There'll be a dot, and then another set of dots, and another set of dots, another set of dots, another set of dots. I'll create a whole field of dots by just randomizing the little slits. Much like the mirror, right, this beam splitter in the interferometer. So the interferometer is doing the same thing as this. Okay, it's creating a diffraction gradient. A bunch of little holes, little slits that are in different positions. One of the slits is going this way, one of the slits is going that way, one's going this way, one's going this way. So they're all randomized. And so you're ending up basically spreading the beam in all directions, up and down, in and out. Okay, and you're creating pattern in all kinds of different places. But the key factor is your divergence is huge. See, if she was doing that experiment just a couple inches from the surface, you can see how big that pattern is. If she was doing that with a double slit, you wouldn't be able to see the pattern. The pattern would be the size of one of those dots. You wouldn't even be able to see the on-off pattern because it would be too small. It would be too unmagnified. So you wouldn't even see it. It's so small compared to that huge pattern. I mean, these are really important distinctions, really important facts, and they just gloss all over them.
Data is stored on the CD in form of small pits. These pits are...
So you can see right there, they all have the same alignment. Okay, so you're only going to get the pattern in the one dimension, the lengthwise dimension. You're not going to get the pattern, you know what I'm saying, the perpendicular to the lengthwise dimension. So the pattern would go up and down in that case, because that's where you're going to lie more likely to hit a surface. There's still surfaces going the other way, but the amount of area that has surfaces going this way is tiny compared to the amount of area where surfaces are going this way. That's why the pattern forms in the one direction.
Several hundred nanometers wide, which is about the same as the wavelength of visible...
Which is kind of irrelevant. Okay, so this whole idea that it matters what size the slits are. I can make them smaller, I can make them larger, I'll get the same pattern, and all I do is change the distances.
Light. This is why CDs create these nice rainbow patterns, because each frequency of light is reflected a little bit differently.
See, so that's where another part where they say something, they really don't have any evidence that the reflection is actually different. The only thing that's different is that the different frequencies can only be combined in different places. So if you're so the idea is the light comes in these different frequencies, you could argue, right, into a slit or whatever your thing is, and they're arguing that somehow the light reacts to the slits differently. It really doesn't. The light is just made out of those things Einstein demonstrated to just be quanta. These individual quanta are all the same. They can't act differently. They're just hitting electrons and doing exactly the same thing. So the red light quanta, right, the ones that are closer together, are exactly the same as these. They're indistinguishable. You couldn't tell them apart. They're identical. They're just at a different frequency. There's no way the slits know that. And all you're really doing is saying, well, I broke a bunch of these, okay, and so now I have a bunch of pieces of photon flying through space. And the question is, where am I going to see the photons where the pieces can be put back together? Well, the fact is that if it's a wavelength difference, right, this distance from this distance is one wavelength, then you can sort of just figure out that there's going to be a high likelihood that this and this will be back on phase. So now I can take two photons that are out of phase, two broken pieces. This plus this will now equal this will now equal a photon I can see. So I can take two broken photons, have them fall in the same place, and those two broken photons will be put back into phase and be converted back into something I will see as a reflection off the surface, because now the proper energy can hit at this location because I put them back on phase. So the key is getting the pieces back on phase. The same amount of energy is hitting here right next to it, okay? But the problem is this wavelength is different. So now I put together these two, and this wavelength is the wrong wavelength. This won't be seen as a photon because this distance isn't the same as this distance or this distance. So it's not a consistent ray, it's not the photon, it won't be seen. The energy hit here, you just won't see it as a photon because the pieces aren't the whole. The pieces aren't going to be able to be put back together. So you'll put reds together here, and you'll put blues together here, and it'll all add up because of this distance. And that's it. So as if I move it closer, this means that there's less of this distance, there's less distance change between the two sides, and therefore I'm more and more on phase. And that's all there is.
Laser light only contains one frequency. If the light is returned from the CD, it comes back in rays.
Alright, so it really isn't. First off, it isn't just one frequency. It's a range of frequencies, but it's a tight range, so it doesn't matter. It's a little red, more red, you know. And they're not always in phase. So the photons, the individual photons coming out of the laser are in different phases. The starting point and the end point are in different places. It's hard to make something that has perfect, coherent laser light. They try really hard, but it's really hard to have all the photons coming out at exactly the same phase. Not easy to do.
Waves, and these can interfere with each other. This is what causes several maxima and minima, and this is what creates the separate...
So she draws the single slit pattern kind of thing, blah, blah, blah. We know that's not what's doing it, right? Because we know that all those lumpy patterns are hitting the surfaces. Lots of little single slit patterns are falling all over the surface. And somehow, though, they only add up to these big humps, all right? Way far away from each other. Those are the only ones that are relevant. All those little ones are there, but there's really giant ones in certain locations. And that's the part where, yes, you're putting them back in phase.
Dots. This ability to interfere with itself is a pure wave effect.
So again, she says so, right? So on-off pattern means it's a pure wave effect. You can never have an on-off pattern ever created by anything else by some kind of wave. Nothing else in the universe can create an on-off pattern but some kind of wave interference. It's just not good science to say things like that.
The very same thing happens with a double slit, except that in a double slit...
Obviously, it's not the very same thing. It's a completely different pattern. It produces images. There's all kinds of things that are completely different. Yes, the mechanism is the same in the sense that the light is being changed in its direction. The photons are being broken and changed in their direction. That part's the same, but where you can put them back together again isn't the same.
The light isn't reflected as it is on the CD, but it goes through. It's both a wave and a particle.
So she says so, but they don't believe so. She just showed us they don't care to even talk about particles. They'll always draw it as a wave. They'll talk about electromagnetic wave. They're completely convinced it's a wave. So why bother making this concession to particles? Oh, that's because they're pretending to pay some attention to the evidence that demonstrates it's a particle. It's they'll just, we're pretending the evidence exists. We're pretending the evidence was worthy of a Nobel Prize. But that's all. We're just going to pretend those things. We're just going to say those things like, no, you don't look fat in that dress. You're just going to say it because it's polite to say. You're not going to say it because you believe it. And so it's just a fraud. Just say you don't believe there's any particle element. Say it. Have the honesty to say you don't think Einstein should have got a Nobel Prize because that experiment must be wrong somehow.
Now, unfortunately, I don't have a single photon source. But if I...
Yes, there is no such thing, I would argue, because photons are always, always, always putting together pattern. So it's always dependent on you being able to put together essentially more than one piece of something. So the surface emits lots of little elements, and it's only the elements that have the right frequency that are going to create a photon that you can see. A reflection at the frequency you can see. But there's lots of other pieces hitting your eye. Your eye is getting hit right now with a ton of other energy. It's just in pieces, in forms that can't be resolved as a photon.
I would repeat this experiment for you, and you would see then that the individual particles...
And again, the key element, I would argue the key thing to think about, the one that's really key to the making of the photon, is the idea of the surface moving away from a target. So just think again, the little bits are heading for something, and they can't hit it. So the whole the universe is going to say it's going to know what things are based on the fact that this is going to reflect, and this is going to reflect, and this is going to reflect, and that's how the universe looks. And if I move this surface away at the same speed this stuff is moving, that there's no way I can reflect anything at that time. So while I'm moving it away, nothing can reflect. Nothing, nothing, nothing. So the universe is seeing a zero. Okay, it's not seeing anything coming off the surface. The surface is running away. So it's just like thinking of the Earth as you know, getting a tiny bit smaller and a tiny bit bigger, tiny bit smaller, tiny bit bigger. You can understand the sunlight. There would be a point where there'd be no reflected light. The Earth would be nothing. It would be black, and all of a sudden the Earth would turn on again when it went expanded, and then it would go back to being invisible, and then it would be back on again. Invisible is probably the wrong word to use, right? Because it won't be invisible. You won't be able to see through it. But it will not reflect the light. There'll be no pattern, no energy. So that's the key to making the photon. Isn't so much the putting in of the energy. It's the fact that you've taken, in a moment of time, all the energy away. There is no reflection.
Up to form a pattern that only a wave could have created. The same thing happens for all other types of particles, just at different wavelengths.
So again, you see, they say wave-particle duality for a photon, and then they turn electrons into waves, and Oldsmobiles into waves, and 747s into waves, and planets into waves, and it just goes on. And they pretend that everything is some sort of jellyfish waving through space. It's not the right answer. The jellyfishing is an emergent property. It's what happens when you have pressure in a field and you push into something and you let it relax, and you push in and you push in and push in. It's a pressure gradient. That's all the universe is. And this wave stuff is emergent. It isn't the elemental function. It's a property that comes out of the fundamental properties. Bullets can make waves, but the bullets are individual bullets. Soldiers can make waves. They're individual soldiers.
The particle, the smaller the wavelength, which is why we don't normally see these effects in daily life.
Right. So they're just saying that I can give a basketball an infinitesimally small wavelength, commensurate to its mass, and so it's this huge, giant pile of energy. I have to make it in. You know, when I turn the entire basketball into a photon, that's what they're doing. What kind of photon would it be? Oh, obviously, yes, it would be a preposterously high frequency, 10 to the 500th or whatever frequency. It's just a silly thing to do. The basketball isn't a wave. It's not a jellyfish. It's a bunch of electrons and protons that have momentum. Why are you pretending it's something else?
The heaviest particles that have so far been brought to interfere with themselves are large molecules.
Right, and there's been no demonstration of this one either, right? So if you actually showed the experimental results for these buckyballs, right, these giant atoms, the pattern is almost unresolvable from the noise. It's a terrible image. And on top of that, with these buckyballs, they have no theoretical reason not to be able to shine a piece of photon, a single photon's hitting a very low intensity photons could hit buckyballs. They would disturb them a little bit, but they're not going to destroy their momentum in any kind of critical or horrible way. And the fact is they could tell what slit it went through. And they haven't done that experiment.
It's neither wave nor particle. So then what is light? Light is neither wave nor particle.
It's a special wave. That's all she's going to say here, right? A wave function, which is just, isn't that saying it's a wave? A wave function? How is a wave function not a wave? Of course it's a wave.
Is described by a wave function in the theory of quantum mechanics.
Right, and a wave function isn't even a wave, right? It's a probability distribution. So, you know, I guess you can make a probability distribution look like a wave, I guess. I mean, it would have a lump to it, right? A probability distribution would have a lump to it. So does that mean it's a wave? Because, okay, this is the probability 10% over here and 50% here and, you know, whatever. No. And again, it's not about probability. There is no such thing as probability. There's inevitabilities based on the amount of variables you have in a system. There is no probability. It's just baby talk. If I'm holding dice in my hand and I'm going to throw them, the fact is that every part of the system is inevitable. There isn't any probability anywhere. There isn't any randomness. There isn't any from nowhere. Every single bounce, every single thing that happens is going to be a real thing. Just like when I flip a coin, you could just follow the coin going through every kind of mechanical process, and every one of them will not break the rules of physics. Every of them will be completely consistent with Newtonian physics. All the rules will be obeyed, and I will get what will appear to be a random result, but it's not random at all. It's not probabilistic at all. It's inevitable every time I flip. I mean, they're just breaking logic here in such dramatically excessive ways, and you know, they're not even accounting for what they're really saying with this nonsense, this wave function that they're applying to the elemental functions of the universe. They're saying the universe isn't determined. They're saying there's some random probability generator. It's just a bold statement based on zero evidence.
The wave function tells you what the particle does, and it allows you to compute probabilities for what it does.
So let's understand, it doesn't do anything for a particle. It'll give you no insight to what a specific particle will do unless you know all the variables that are going to affect the particle. So again, all they're saying is if I take a single particle, there's a certain likelihood it hits the surface here, or the surface goes right next to the surface here, or goes right through the center. Duh. We can all surmise that, right? They're saying it doesn't matter whether it goes here, here, or here. That's the probability is the same for all of those different locations. Where I would make the simple argument, no, it isn't. It matters where you are. Just like in a water wave, it matters whether you're a molecule right on the surface, a water molecule, or you're a molecule of water going right through the middle. Those two water molecules will encounter a different environment, and one of them will end up progressing much slower than the other one progresses. And it's a physical reason. There's a real reason the photons have a different outcome. There's a real reason the water molecules have a different outcome. They keep talking as if there's no real reason. There's just the magical probability function. There is no probability function.
Sometimes light behaves a little bit like a particle. Sometimes it behaves a little...
So she just keeps singing the same first verse to the song, and then just says, forget what I just said, because that's crap. We believe in waves. I mean, there's just no point in saying this, but you don't account for it in any way whatsoever. You can't draw it as a particle. You can't talk about it as a particle. You don't do it. You don't make any effort at all to understand how it could be a particle. You just ignore all of those decent models, rational models, so you can just keep playing with your silly model, your wooey, wavy, amorphous fun.
A bit like a wave. But it is really neither. It is described by a wave function.
So here we go again. It's neither, but it looks like that. Yeah, okay. That looks like a wave. Sorry, that doesn't look anything like a particle. So it seems pretty... You just want to use a different word. So you just, instead of saying wave, you'll just say wave function when you're just basically saying the same thing.
The same is true for every other particle or wave.
So then she shows us this idiotic chart of nonsense where they claim these are particles. They don't have rational properties. They call something spin. They don't mean it's spinning. This is just all bullshit. Okay, this whole chart is just full of stuff. They haven't figured out what it is. They see a squiggly line in a cloud chamber. They see this go this way. And they say, oh, it must be a new particle that hit it this way. They can't think, well, maybe it's a cosmic ray that hit it this way. It's other explanations. You don't need a new particle. You just need a piece of energy. Things move because energy can hit them. There's more than one way to move an electron, right? Well, technically, there's only one way. That is to compress force around it, to create a force environment that forces it. So, yes, you always have to use force. Even when an electron hits an electron, the electron never hits the other electron. It hits the force between the two electrons. The force, the ping pong balls. And the ping pong balls bounce faster when the two electrons get closer together.
There isn't such a thing as a particle or wave. It's all wave functions.
There you go. So more mush.
For this reason, one of my profs liked to say that we shouldn't speak of elementary particles. We should instead speak of
jellyfish. Elementary jellyfish. Little randomy, floody, fluey little bullshit jellyfish. It's a jellyfish universe. Yes. The whole universe is made out of little jellyfish. They're all on some sort of mission, and they all have a place to go. No.
Things. Elementar Dinge. But this sounds so stupid that nobody does it.
Right. You don't take any account, again, for what it means that your evidence isn't conclusive, and you just decide where we're going with it. We don't care whether it's the right or wrong answers. We're just not scientists. We don't do that science thing. We're doing the religion thing. We want to get it way ahead of the curve. So we want to have a complete theory and be way ahead of everybody else because we already got the right answer, even though it's the wrong answer. And then maybe it'll take actually 1,000 years, like with religion, to actually get to the truth, because you people are just, that's what human beings do. They're just devotees of bullshit. Their little comfort, because it makes them feel right with the universe. They'll turn anything into anything. They'll make animals edible, but through some sort of bizarre circumstance where they pretend they don't feel anything. They don't have brains for a reason. The same reason we have one. Theirs is doing something completely different, of course. It's not worrying or afraid or in pain. No, it doesn't do any of those silly things. Oh, fuck you people.
So just keep in mind, whenever somebody talks of a particle, they are just being lazy.
Right, well, whatever. There's clearly a difference between a water wave and a bullet, okay? A stream of bullets or a stream of soldiers. So it can be understood that there is a real distinction here, that there's a truth underlying here. Either it's made out of discrete stuff moving the speed of light, as Einstein's theory fit the evidence, or it's this, whatever you think it is, these 500 fields that are all wobbling in some way, and the fields only understand each other or communicate with each other through who knows what mechanism. Yeah, it doesn't make any sense. Yes, sorry, I don't even want to go there because there's no way to make it make any sense.
There isn't any such thing as a particle. It's all just wave functions.
Which is saying absolutely nothing. I mean, it's all just what? Probability. No, it isn't just all probability. And again, it can be demonstrated in every single thing that we see as random. We know it's not random. I can't even with all the computer technology in the world, right? Like Humpty Dumpty, all the horses men, all the kings, all the horses, all the men's horses, all the king's horses, and all the king's men can't make a random generator. They can't do it. There's no physical science that will allow you, with all the computing power in the world, to create an actual random number generator. You just can't do it. All you can do is create a facsimile, but it is by definition, by theory, it's incomplete. It's underdone. There's no random. There's no wave function from magic. There's wave function from circumstance. It matters whether the photon goes next to the surface or the photon goes through the middle. It matters.
If you ask a physicist what light is, they will probably tell you it's the gauge boson of the U1-Young-Mills theory.
Oh, great. I mean, wonderful. I mean, yes, they'll just be more evasive Latin crapola to evade having to say anything rational.
This means in particular that it exchanges an interaction between elementary things that carry a conserved charge.
So more conserved charge, and what all that means is you know what they can tell you? What they could tell you is that the universe has a pressure in it. All right, it has an innate pressure, an innate stuff in it. Okay, and that if you put stuff in that stuff, you'll change the pressure. You'll have places where there'll now be low pressure, and somewhere else, because you made low pressure here, the pressure has to go somewhere, so there's going to be high pressure over here. And that's going to be the conservation. You'll always have conservation of pressure, but in any one little box of the universe, because of the way things are connected to each other, you can have varying degrees. But the net universe will always be the same amount of stuff in it. There's always the same amount of energy, and the photon is just one element reflecting the fact that you can create circumstances where there's no energy for a moment in time, and the next moment in time there's twice as much energy, and then there's zero, and then there's twice as much, and then there's zero, and then there's twice as much.
These are the electrons. But if somebody asks you on the street whether light is a wave or a particle, what you say is, it's neither. It's described by a wave function.
It's described by a fake probability random number generator that is theoretically impossible to have, but we believe in it because we're religious kooks. Why don't you just tell them? Why don't you just go to Jehovah's Witness meetings to figure out how to make proper religious videos? Because that's all this is. You're just propagandizing for a theory that's so underproven, it's ridiculously underproven. Alright. Just awful. Gibberish. Sorry, it's just gibberish. It's just junk, garbage, made up phantom functions. Again, they say that when I flip the penny on my thumb, they're saying, no, that's a wave function. Now you do know, right? You do understand that I can take a slow motion camera and I can watch almost every bit of the momentum changes in the action. I can see the action. And I can know that it's not for some random reason that it turns a specific way through the air, and that each one of those motions has a Newtonian reality, not some sort of what's its probability function, what's its random, what did the random god say it should do? The random god isn't deciding any of this. Anyway, it's just, I just don't know why. Like I said, this is just such a silly argument to have with people who are supposed to be intelligent. You won't admit your evidence absolutely sucks. It is so frickin' weak. You have jumped to a conclusion, like the guy saying, well, the giraffe reaches higher each time, and you know, it's willing its neck to get longer. By stretching it, it wills it to get longer, and that changes its genetic code because it's trying to make its neck longer, and so when it has a baby, the baby will have a longer neck because it tried to have a longer neck. I mean, it's a silly... It doesn't make any sense when you even think about how would that actually take place. You mean our will is converted into the seed? Somehow my seed? You know, that junk that, you know... that they knew back then that there was stuff that made babies, right? They really think the stuff has in it what I thought today? I mean, it didn't make any sense. It's a silly theory. It's unevidenced. It's just stupid. And they're doing the same thing. What exactly? Where's the comparable difference? How have they not failed to pervert the evidence completely? I mean, succeeded just as much as the, whatever that guy's name was, theory of evolution. It's a lousy, rotten, weak, silly theory. It doesn't explain the reality in any kind of deep way. And it's not consistent with all the new evidence. All the new evidence indicates that's a pile of crap. All right. No, there's just no hope. Religions die hard. There's no evidence they die, right? They're just so hard to kill. People are just so frickin' stupid. So this is, they'd be proud to send this to outer space, right? So she thinks this is a great video about the facts of life, and she'd be glad to send this to the aliens, demonstrating to the aliens how smart we are. Let's send quantum theory and your standard model and your wave particle duality and your wave function crap to the aliens. You really think they're going to be impressed and go, wow, yeah, you really got something there. We thought it was a deterministic universe based on pressure mediation, and no. Instead, it's this whack-a-verse, whack-a-mole bullshit. You really think this terribly under-evidenced theory, why, again, so under-evidenced. Oh, it's an on-off pattern. It's got to be wave interference. Nothing else could make on and off. The simplest pattern in the universe couldn't possibly be made by more than one thing. I've made all these arguments. It's just, just talking to a farty wind. Wind just people think with your asses. You're just wasting brain space. What are you using? You're just, you're all just playing video games or, watching tripey television. So, yeah, it's all over your heads. That'll be my new sign off.